Thank you much, Jan.
Sure.
So if you want to fill out that survey now and save yourself some time and effort, go ahead. Uh, that's a joke. So let me share with you what I see as the objectives for today. First of all, we want to talk about what the conventional view of risk-based testing is and why, and identify how to take advantage of the fact that all testing is risk-based, and, and look at a couple of ways to assess risk for testing, because people apply a variety of techniques and they're not all created equal. Now, let me give you a little bit of background. This exercise from one of my test management courses uh, led me to a recognition of something that, frankly, I hadn't really exactly expected. And so you can read this. You're the test manager for a major system with a scheduled 6 months total project duration. Your test group is to do the system test in months 5 and 6, and you have some concerns. You feel that 2 months of testing by your small group is way too little. You suspect that the developers will be late getting the code to test, so you may not be able to actually do it in months 5 and 6. And surprise, surprise, previous projects had quality problems when testing was squeezed. And then what I ask the members of the class, then they work in teams, to identify the points that they would raise to convince management to give them what they need. And then what are management's likely responses and why? Now, because we're squeezed here, we're not going to have time for you to actually carry this out, although I think you might find it interesting to make a quick set of judgments. But I'm going to jump right to sharing with you what I found from group after group carrying out this exercise. First of all, they point out that inadequate amount of testing in the past led to trouble. And so they said, therefore, we need more time to test. And 2 months of testing is too little. Once again, they need more time to test. Test group is too small. They need more testers. Errors are often in the requirements and design, so involve the testers earlier. Make development, the folks in development deliver the code in time to test it, preferably in multiple smaller and mainly earlier releases. Cut the functionality to what we can test in a given amount of time. Now, I would guess that these issues and these responses are probably pretty familiar for a lot of you. Notice the theme. We need more time. We need more people. We need the developers to deliver it earlier, cut the functionality, blah, 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 blah. And then everybody, regardless of what organization they're from, recognizes that management is going to say no to all of those seemingly reasonable tester requests. And then there are lots and lots of reasons, but they're basically, management says, we've got to get this done. We don't have more time. We don't have more resources. Just suck it up and do it. And then the testers, as a last resort, say, oh, let's do risk-based testing. We'll just test the things that are highest risk and not all the other stuff. Okay? Now, perhaps you're familiar with the same type of thinking. Okay? And so what do we learn from it about the common perceptions about risk-based testing? First of all, that people treat risk-based testing as somehow a special technique. Okay? one that isn't ordinarily done, and it only is done when there is explicit risk analysis and typically as a last resort. Now, once again, there's a good chance that maybe some of these things look familiar to you, and perhaps you can see why these perceptions are A, not right, and B, not helpful. Okay. They're nonsense because all testing is risk-based. Now, risk-based testing does not have to be conscious. It doesn't have to be explicit. A lot of people think that they're only doing risk-based testing if they have an explicit risk analysis activity. But in fact, we do risk analysis all the time, often unconsciously, often implicitly. And that's because testing is our main method of reducing risks in systems and software. And there's a simple relationship. The more risk, the more testing needs to be done. And we think this way, whether we're doing it consciously and explicitly or unconsciously and implicitly. If we do it unconsciously, okay, if we decide what to test first, what to test more, what to retest, okay, if we're doing that unconsciously and implicitly, that tends to affect the reliability of those decisions. They're more likely to be wrong when they're not conscious and explicit. And they're especially likely to be wrong because they're likely to miss things. Perhaps you're familiar with risk management in general. So risk management is not just a testing, software testing activity. It occurs in all types of contexts. And there's a set of steps that, frankly, always need to occur. Identifying potential risks, prioritizing them. That can be done qualitatively and or quantitatively. Assess the causes of the risks. Figure out what to do about them. You could accept the risk, or you could have some kind of a mitigation strategy. One of the mitigation strategies is avoid doing the risky thing. So, for instance, I don't know about you, but I do not do skydiving. I think that it's a kind of a silly thing to jump out of an airplane and expect not to kill myself on the way down. Okay? If you're not avoiding it, you can control the likelihood and or the impact of it. So, for instance, in an automobile, we have seat belts. Seat belts are there to reduce the impact, literally, if we have an impact. And we also have all manner of things to reduce the likelihood of an automobile accident, such as having a designated driver. Don't drive if you've been drinking. The speed limits are there to help us stay safe. Okay? And sometimes we can transfer some or even all of the risk. So the most common ways to transfer risk are through insurance and also things like outsourcing, hiring a consultant or an expert. And then we need a contingency plan, what to do in case the risk occurs. Now, notice steps 1 through 5 are all planning activities. Step 6 is the one that's too often not done. That's actually implementing the strategy, monitoring it, and controlling it. So if you don't do all 6, you really are not managing risk. Okay? Testing, which a lot of us in this session are involved with, testing is a primary way for controlling the likelihood of a risk occurring. That's what testing is really about, and sometimes also able to control the impact. Classic testing maintains what's called a risk register. The risk register is simply the place where you keep risk-related information together. You know, what the risk is, the causes, et cetera, et cetera. And the part, once again, that people don't do, and therefore it tends not to get recorded in the risk register, is actually monitoring, controlling, and reporting, including the actual costs and effort of detecting risks, of responding to them, and the harm that occurs in spite of detection and response. Okay. Also identifying risks that occur that had not previously been identified, analyzing and identifying the reasons that we might have missed a risk, and what we should do the next time so that that type of a risk doesn't occur again or doesn't have the same impact. So risk has two major elements. Impact, so how severe the damage is. We've just seen that a Category 5 hurricane will probably cause much more severe damage than a Category 1 hurricane. The higher speed, higher wind speeds knock down more trees and blow a bigger storm surge and so forth. The number of people that are affected. So if we've just seen two hurricanes that hit a lot of heavily populated areas. Now, Hurricane Helene also went through a bunch of other areas that were not so heavily populated, still inflicted severe damage, but not as many people were affected. Consequences. You can be out of business. So a hurricane that shuts down the electric power, if you're, say, a restaurant and you've got a walk-in freezer full of food to cook and prepare, and you lose power, you're going to lose all of that food. And that loss could literally put that restaurant out of business. What we in the software world tend to pay most attention to is what's involved in the cost, the time, the effort, and our ability to fix the problems. And impact is diminished when there are workarounds. The other element of risk is likelihood that it will occur. And the bigger and more complex something is, the more likely it is to have problems, and the more likely it is that they'll be harder to detect. If we are using technology that is new to the world, it's going to have problems that haven't been detected yet. If you're using technology that's not new to the world, but new to your organization, it's also going to be likely to have problems that you're not accustomed to, you're not familiar with, and not able to deal with as well as perhaps people in an organization with more familiarity. Some of you are familiar with the mutual fund ads that say past performance does not predict future performance. In the risk world, past performance does predict future performance. You know that if you are dealing with, for instance, a software product that has had trouble in the past, you're on notice it's likely to have trouble in the future. And even though it is not politically correct, who produced the software is a significant determinant of the likelihood of problems. you know that you work with some developers whose code is rock solid, and you work with other developers whose code is a nightmare. You're on notice that when you're dealing with the developers that historically produce bad code, you need to test it more. And then there are other things like lack of skill, lack of motivation, inadequate methods, and so forth. Now, risk is also referred to as risk exposure, which is calculated as the impact times the likelihood. And in the software world, there's a traditional view of risk analysis, which says look at each feature and each component. So, what it does and how it does it, and ascertain for each of those what's the impact if it goes bad, what's the likelihood that it will go bad. You know, what are the vulnerabilities if things fail? What are the things that will trigger failure? Situations where things are likely to fail. And what are the impacts of failure of those particular features and components in terms of quality, cost, schedule, damage to individuals, and so forth. And then we prioritize and test the highest risk things most. So some of the things that contribute to that are things that are done the most and things that other things depend upon. So for instance, most testing inordinately tests login. Login is actually a pretty insignificant part of functionality, but if you can't get logged in, nothing else much matters. Things that are likely to fail, things that are big and complex, and especially things that have changed, things that absolutely positively must work. I think that was one of the slogans of FedEx or UPS or both of them. Now, simple question. If you are dealing with a high-risk situation, does that mean that your organization gives you additional test time and resources? And the likely answer is the same as in the exercise earlier, no. So when we are identifying and analyzing risks, one of the biggest challenges is reliably rating the risks. And at a minimum, that's typically done just high, medium, or low. So in my experience, the most common way that risk is evaluated is by rating. You look at each individual risk and you make a judgment, high, medium, low. And generally, when organizations, teams are doing risk analysis, they're largely relying on subjective judgment, presumably by knowledgeable people. Now, those judgments can be enhanced, made more reliable by guiding them with checklists of common risks. That's a fairly common thing, and I'm sure many of you are familiar with checklists of common risks. My experience is that the checklists identify the common risk situations, but very seldom provide any meaningful guidance for reliably differentiating whether a risk is high, medium, or low. So one of the things that I would suggest is that you pay attention to objectively identifying the respective characteristics of high, medium, and low risks. So for instance, for a given situation, low risk sometimes is referred to as cosmetic risk. Maybe that's a situation where there are no interfaces with other systems. Medium risk would cause something, the working to be impeded, but not stopped. Maybe that's if there's interfaces with one or two other systems. And high risk, maybe stuff doesn't work at all. Maybe that occurs if there are interfaces with three or more systems. These are simply examples of how you might state this. I'm not suggesting that you use these in your own work. Many of you are familiar with graphical representations of risk. And so we have impact on the one axis and likelihood on the other axis, low, medium, and high. So a low impact, low likelihood risk, okay, is where we've got the white. Okay. Medium and medium would be those four. Okay. High and high would be those nine. So that's a graphical representation. Okay. Now that is qualitative risk analysis, high, medium, and low. That's qualitative. Quantitative is where numbers are assigned. Now notice it's the same categorization, but people believe, and you can question the wisdom of this, they believe that if it's described with numbers rather than words, that somehow that's quantified and superior. Okay. And so once again, you calculate the risk exposure, the impact score times the likelihood score, and you get a range of 1 to 9 with this diagram. Now, here's the funny thing. Figures don't lie, but liars figure. It's very common that people might use a different scale. So if they use a 1 to 5 scale, notice on a 1 to 5 scale, a risk exposure score of 25 is high, high. On a 1 to 3 scale, a risk exposure score of 9 is high, high. It's identical risk, but the 1 to 25 looks a lot bigger. And then, oh, well, how about if we make it 1 to 10? Then we've got 100. Oh, that seems even bigger. Okay. Now, sometimes this is also done in a nonlinear fashion to give greater emphasis either to impact or likelihood. And sometimes people do this and refer to it as percentages. Be very cautious about that. When people tell you that there's a 73% risk or whatever, some number like that, recognize that that's a number that probably has no basis in reality. So prioritization is figuring out which of the risks are most important. And if you rate, score each risk, high, medium, low, etc. Okay. First of all, that takes a lot of time, especially if you've got quite a few risks identified. But the bigger issue is that it does not prioritize well, because it's very hard for people to make meaningful distinctions among the high, medium, and low. And people tend not to be consistent. And the biggest problem is that when people rate, practically everything turns out to be high, high. So if everything is top priority, then nothing is top priority, because the priority is not making a differentiation. So as a practical matter, prioritization is most effective when it forces distinctions. And when you force distinctions, the technique of ranking is the one that forces distinctions. The problem with ranking is that humans have a very limited attention span. And if they have to rank more than 5 or 6 or 7 or 8 or 9 choices, and people vary in their ability to handle that, it's referred to as the magic number 7 plus or minus 2. Okay? If they're trying to rank more than 7 or 8 or 9 choices, they lose the ability to differentiate. Now, if you look at most of what is written and said about risk, most of it is based upon project management risks. Okay? And project management risks concentrate on things like lack of time, lack of budget, lack of resources. And resources and budget are tightly coupled. Also, if you're getting guidance, quote unquote, from people above you with regard to risk, there's a pretty good chance that they're thinking in terms of project management risk. Lack of time, lack of budget, lack of resources. Okay? Those are important. They do indicate the amount of risk, but they aren't very helpful for guiding which testing you need to prioritize. And so a lot of the classical project management training and thinking really is not very relevant to risk analysis with regard to testing. Something that is very relevant is the difference between causes and effects. And this is a distinction which, unfortunately, a lot of people don't appreciate and therefore don't make or make properly. So effect, that is the exposure, the impact times the likelihood. That is why we care about risk. That is the bad outcomes that we are concerned will occur. Notice that there can be business effects, there can be management effects, there can be product and technical effects. We need to be attentive to all of those. Causes are what we can address to mitigate, either reduce and or eliminate the effects. So effects, that's why we care. Causes are what we can deal with to try to reduce or eliminate the effects. And testing, as I mentioned, is our main mitigation technique, identifying where the risks are, giving us confidence whether or not the risks have been handled properly. Now, I will suggest to you, and this is more than we can get into here, that testing as a risk mitigation technique is more relevant than we often realize, that it pertains to a lot more than we tend to appreciate, because it pertains to business and management as well as product and technical risks. But the other side of it is that there are things that software testing is simply not relevant for. Some of those we've kind of alluded to in project management risks. You don't have enough resources or time or so forth. Okay. What people tend to do is focus on the causes, the things that trigger the risk's occurrence. Focusing on causes gives us absolutely no basis for prioritization. Prioritization is meaningful only with regard to effects. Now, a lot of people spend a lot of time classifying various types of risks. This is a list of some of the ones that I've bumped into. Okay. In your situation, some of those may be more important than others. Natural risks is very critical to people in Florida these days. Okay. A month ago, not so much, and so forth. So consider a typical testing approach. It's very common that you create a bunch of tests. Let's say you've created 100 test cases. You have time to run 10 of them. Well, test cases represent small risks, and the 100 there, prioritizing them could be pretty time consuming. But what you tend not to be attentive to is what's the value of the time you spent creating those 90 tests that you didn't have time to run. That's time that's been wasted. And where are the other test cases you didn't even think of? And in the other side of that is, in hindsight, were these 100 test cases even the ones that were testing the most important things? And I would suggest that often the answers to those are no. Now, I'll give you a small shout out for my proactive testing methodology, which deals with risk considerably different. So, typical testing focuses on test cases, which are small risks. Proactive testing focuses first on large risks, then medium-sized risks, and then the small risks. Okay? And proactive testing has a variety of special techniques to help identify ordinarily overlooked risks. Okay? A lot of them are due to problems in the design. And when we identify these risks earlier, we catch them in the design before they get into the code. Okay? And we have the ability to zero in on the highest risks so that we're only spending time on the risks that we're actually going to test for, creating tests for those risks. I use the phrase, let testing drive development. That is, we analyze risks and then we build the system so that we can test the high risk pieces first. And we do that before we build other stuff that might be dependent upon those high risk things not occurring. So if the typical development approach ends up having to do a lot of rework because high risks occur that impact a lot of code. And we plan and design proactive user acceptance testing, which takes a different approach for early execution and for planning and designing it early for execution at the end. Okay? And that includes not only requirements-based tests, but also what I call proactive user acceptance criteria. Recognize that this is not the same as user story acceptance criteria. Okay? And what this does is it gives the technical and development people a much bigger heads up on what the business people are looking for so that they can be sure that if in their testing that they've already caught these things before they get through to technical and traditional user acceptance testing. Let me give you an example, graphical example of how we let testing drive development. So let's say we have a system that consists of modules A, B, and C. Typically, we would test module A, then module B, then module C, then we'd integration test A's and B and C together, and then all together. But let's say that we have ascertained that the highest risk is the integration of modules B and C. Well, then, instead of starting with module A, let's start with modules B and C and get that highest risk cleared out, because there's a good chance that the way that modules B and C are designed might have some relationship to the way module A is designed. And if we have to redesign B and or C, we probably have to go back and throw out and redesign some of module A. Next highest risk is the message capacity of module A. So let's split module A into two pieces, the part that's dealing with the messaging and the rest of the program. Okay? And the third highest risk is the overall integration of A, B, and C. Okay? Well, now we've got B, C, and A working much more reliably. So when we put them all together, they're going to be much easier to test and much more likely to be in good shape. So let's go back and review. We've looked at the conventional view of risk-based testing and why it's wrong. People tend to think that it's a special type of test, that it's only when it's late in the process, and it's only if you do risk analysis explicitly. None of those is true because all testing is risk-based. Okay? And therefore, we can and should incorporate risk analysis into all of our test planning and design. And we've looked at the differences between rating and ranking as ways for assessing the risk for testing. And I will suggest to you that the ranking turns out to be much more productive. This is a diagram of some of the courses in consulting that I do and their relationship to the various life cycle phases, okay, including courses on proactive user acceptance testing and proactive testing and risk analysis. I'll be glad to discuss any of these with you offline. You can reach me at robin@gopromanagement.com. And so, Jan, how do we do here?
We're doing well on time. It's 3:08, so we have probably about 12 more minutes.
Good.
Open
Any
up
questions?
Yeah. And you can put them either in the chat or just ask them, whatever you're most comfortable with.
If you want to ask, you have to unmute yourself.
Of course. Exactly.
Well, as an experienced unmuter, I know that people forget that.
Oh, yeah.
So have you got any in the chat?
Not yet. Don't see anything yet.
Okay, well, I've obviously dumbfounded people.
Or they've all do this way all the whole time. We actually do in our test plan, we always have to put down all the risks and then the mitigating strategies. And it has to be approved by everybody in the test group or PM or whoever. So
Good. I'm glad to hear that. That's a big improvement over it being an afterthought.
Yeah. No, it takes a long time, but seems like it's worth it.
Takes a lot less time than having a problem get through. That's a big risk.
No, that's true. The other thing that we do is usually we have a list of severity and priority already defined out there. And we don't say so much, we don't really name so much common risk. We just name types of risk. I'm trying to think of a good example with that. I can't remember off the top of my head. But it always seems to help if we get them to agree to the definition beforehand.
Absolutely. Then everybody's playing by the same rules.
Yeah.
And then afterward, do you analyze and evaluate how well you did and update your risk categories?
Then that's one thing, of course we have, agile retrospective, but we don't always, we don't always do that.
Yeah. Agile tends not to be real good at this stuff. Yeah. I tend to assume that being agile covers all the bases, and that's not a good assumption.
Yep.
Looks like we've got a question.
Yeah, not a question, Robin. Thanks for the great presentation and knowledge sharing. Thanks, Jan. I think, as Jan mentioned, we also go with phased manner deliveries. That means we look for the MVP for the phase one, what we deliver, and there itself we try to risk analysis. And also, once the primary delivery is done, we do the retros, agile level retros, which includes product development and quality assurance. And we look into that and based, and also once the delivery is done, based on the incidents what we receive uh, on the new product launch, we prioritize them as mentioned, and we quantitatively measure and we go with the priority, and we try to resolve them and go in the flow. Yeah, we kind of follow, and there are good tips what we need to implement, looks like. Yeah, thanks.
And how do you quantify the 1, 2, 3 type of approach?
Yeah, 1, 2, 3 type of approach, priority and severity both we look into, and based on that, we also look into if it is a production incident, which where we definitely losing some money, we go as a hot fixer. We put all our efforts there and try to fix it. And let's say cross portfolio issues, we take that as a priority too and try to unblock the other portfolios and make things work better. And like that, yeah, we go with that quantitative priority.
Yeah. Now, recognize once again that the calling high, medium, low, 1, 2, 3 does not change the fact that it's a qualitative judgment. It's a guess. Contrast that with companies that are actually in the risk business. Airlines know precisely how long it takes them to get from one spot to another spot. They know how often they're late, by how much extra gas it takes, and so forth. They are truly measuring and quantifying their risk. Okay. That's not, may not be workable for most of us, but there might be more workability there than you might imagine. Especially if you're, in industries like telecom. Okay. There's a lot of sophisticated risk analysis that can and probably is done there, although maybe not in the software testing world.
Yeah, and often one tricky thing I would like to bring up is sometimes as a QAs, we identify some of the issues earlier in the stages, but the severity is given very low, and that's been kept aside, right? Once the product is launched and once that comes from the business saying like, okay, I'm not seeing this asterisk, and it's if that comes from a top level management, that becomes severity number one, and high priority is given. It gets fixed that time, not when we raise. So I don't know how that can be handled, but yeah.
That's another common experience, that the loudest person or the highest paid person in the room tends to prevail, which sometimes is okay and sometimes leads us astray.
Yeah.
We've actually had, I've experienced a similar thing where, yeah, you bring up the risk early as a QA, and that no one pays attention until the business actually says something, which is sometimes too late.
Yeah, the Challenger disaster is, of course, the best known example. But yeah, after the fact, oh, we all knew the O-rings would fail. Well, nobody seemed to know it, in time to prevent it.
Do you think it's ever effective to go to the business earlier with the risk? Maybe, the certain people who
Absolutely.
Yeah.
Absolutely. They're the ones that suffer. I mean, yeah. Most organizations are not there to create software. The software is there to help the organization do something useful.
But sometimes that can be a little bit hard because that can kind of rock the boat a little bit. I mean, it's
Oh, yeah.
I think the most effective. So if you have any recommendations for how to do that without rocking the boat, would certainly be all ears.
Well, the first of all, involve the business people as well as the software people
Yep.
in your risk analysis. So it becomes their issue, not yours.